In this video, we're solving exponential equations, equations where the x is up in the power. There are two methods, and picking the wrong one wastes half the question. Look at these two. They look almost identical. They are not the same problem. 32 is a power of 2. It's 2 to the 5th. So the left one you can do in your head. If 2 to the x equals 2 to the 5th, then x is 5. Done. No calculator, no logs. 30 is not a power of 2. There's nothing you can rewrite it as. So that one needs logs. And that is the only decision you ever have to make in this topic. Can I write both sides with the same base? Yes or no? Yes, match the powers. No, take logs. So, method 1. Same base. If b to the m equals b to the n, then m equals n. If the bases match, the powers must match. That's the whole step. Method 2. Take logs of both sides. And the power rule from last video drops the x down to the front. X times log b equals log a. Then divide. X equals log a over log b. So let's finish the one from the start. 2 to the x equals 30. Take logs. X is log 30 over log 2. That's 1.477 over 0.301. 4.907. And always do that last check. 2 to the 4th is 16. 2 to the 5th is 32. So the answer has to land just below 5. And it does. If your calculator gives you something outside that range, you've mistyped it. You haven't discovered something. Example 1. Solve 3 to the x equals 81. 81 is a power of 3. It's 3 to the 4th. So 3 to the x equals 3 to the 4th, and x is 4. Example 2. Solve 4 to the x equals 8. Now neither side is a power of the other. But look again, they're both powers of 2. 4 is 2 squared, and 8 is 2 cubed. So 2 squared, all to the x, is 2 cubed. That's 2 to the 2x equals 2 to the 3. So 2x equals 3, and x is 1.5. Check it. 4 to the power 1.5 is 8, and that's the lesson. When the bases don't match, look for a base they share. Example 3. Solve 9 to the x equals 27 to the power x minus 1. Both are powers of 3. 9 is 3 squared. 27 is 3 cubed. So 3 to the 2x equals 3 to the 3 times x minus 1. Bases match, so the powers match. 2x equals 3 times x minus 1. And watch that bracket. It's 3x minus 3, not 3x minus 1. That missing bracket is the single most common lost mark in this topic. So 2x equals 3x minus 3, which gives x equals 3. Check it. 9 cubed is 729, and 27 squared is also 729. Example 4. Solve 5 to the x equals 40. 40 is not a power of 5, so this one needs logs. X is log 40 over log 5. Bracket it first. 5 squared is 25. 5 cubed is 125. So x is between 2 and 3. Log 40 is 1.602. Log 5 is 0.699. That gives 2.292 inside the bracket, so it's believable. And here's one worth seeing next to it. E to the x equals 7. Same method, but use the natural log instead, and it's one button. X is ln7, 1.946. Last one. Solve 2 to the 2x minus 3 times 2 to the x minus 4 equals 0. First thing, 2 to the 2x is 2 to the x all squared. It is not 2 times 2 to the x. Get that wrong and nothing else works. So substitute. Let y equal 2 to the x. Then it's y squared minus 3y minus 4 equals 0. That factorizes. Y minus 4 times y plus 1. So y is 4 or y is minus 1. Now go back. 2 to the x equals 4, so x is 2. But 2 to the x equals minus 1 has no solution at all. An exponential is always positive. It can never output a negative number. So that root is discarded, not answered. Check the survivor. 16 minus 12 minus 4 is 0. So, same base if you can, logs if you can't. And if the x appears twice, look for a hidden quadratic. Next video is the mirror image of this one. The x is inside the log instead of up in the power. Solving logarithmic equations.